Use the factor theorem to determine if x minus 2 and x plus 1 are factors of this equation. Okay? So, since they already tell us what two potential factors are, I don't need to do P over Q. I'm just going to use these numbers with synthetic division. So if this is x minus 2, if I set that equal to 0, that means my first potential factor could be a positive 2. So then I'm going to pull the coefficients from all of these terms. So if there's no number there, I could put a 1, so that's 1. And then this is negative 2, and then negative 9. 32, and negative 28. I'm going to bring down this 1. I'm going to multiply times my potential factor, which is 2. So 2 times 1 is 2. Negative 2, and this is a positive 2, so that's 0. 2 times 0 is 0. Negative 9 and 0 makes negative 9. Negative 9 times 2 is negative 18. 32 minus 18 is 14. 14 times 2 is 28. Negative 28 and then positive 28 is 0. Since my remainder is 0, that means it is a factor. So x minus 2 is a factor. And then it says to use the binomials and their factors to write a factored form of f of x. So I'm going to use x minus 2. And then I'm going to take my reduced polynomial and write that. So that's 1 x to the third. Because my original equation is x to the fourth. So if I take one factor out, that's going to be 1x less. So that's x to the third. And then this is 0x squared, so I don't need to write that, minus 9x, and then plus 14. Okay. Now I'm going to check x plus 1, so my potential factor is x minus 1. I'm going to use 1, negative 2, negative 9, 32, minus 28. Bring down the 1. 1 times negative 1 is negative 1. Negative 2 and negative 1 make negative 3. Negative 1 times negative 3 is a positive 3. Negative 9 plus 3 is negative 6. Negative 1 times negative 6 is positive 6. 32 and 6 makes 38. 38 times negative 1 is negative 38, and so that is going to be negative 66. Okay. Since my remainder is not 0, that means x plus 1 is not a factor.